Okay, last but not least, we have the intermediate value theorem, also called IVT in calculus. This is one of the biggest theorems in the class, even though it's only in chapter 1. It says if the function f is continuous between a and b, and it's a closed interval, so it has to hit both endpoints, and k is any number between f of a and f of b, then there exists at least one number c on the interval ab such that f of c is k. What the heck does that mean? Well, here's what it means. I made a picture for you, and I'm going to illustrate this with a bit of a story. Let's say that A, right here, in f of A, is a city in the western United States. I'm going to say it's Billings, Montana. I've never been to Billings, but I'm sure it's a rockin' town. And then let's put B, comma, f of B. We'll make it a city in Canada. How about Regina? I've never been to Saskatchewan either. I really got to get around. Okay, so anyway, here's the story. Let's say that you spent a Friday night in Billings, Montana, and you had a really good time. So good that you woke up Saturday morning and you were in Regina. And you're like, what in the world happened? Well, I don't know exactly what happened, but I'll tell you one thing I do know. You crossed the border, at least once. You had to. So if this is the U.S.-Canadian border right here, the function's continuous. You didn't teleport yourself to Regina. You know, it's not like Star Trek or anything. You had to cross the border at least once, somewhere between Billings and Regina. Maybe you crossed the border right away and stayed in Canada. Or maybe that didn't happen. Maybe you stayed in the U.S. and then right at the last minute you're like, let's go to Canada. Or maybe you, I don't know, taunted the border guards until finally they're going to arrest you and you're like, all right, fine, we'll just stay in Canada. But you have to have one number, and that number is called C. Anytime, C for crossing, I guess, anytime you cross the border, that's going to be x equals C. And C has to be between A and B. It has to be between Billings and Regina. Which makes sense, because if you come back to Regina and you cross the border, I guess you have to cross the border over here. That's not a function anymore. That fails the vertical line test. So that's why this has to be there. So that's called the IVT. It seems like common sense, and I guess it kind of is, but man, is it useful later on in calc. And it almost always appears on the free response part of the AP exam at least once in one of the 6 questions. All right, we're going to go ahead and put the IVT to use. Okay, first of all, verify that we can use the theorem. All right, is the function continuous? Well, yes, it's parabolic still. Okay, so we're safe. Let's try the 1 in. If you try the 1 in, you're going to get 2 minus 11 plus 5. That's going to be negative 4. Of course, if you try the 6 in, you're going to get 72 minus 66 plus 5, which is 11. So I think you can see that, yeah, you got negative 4, positive 11. 4 is in between them. So the intermediate value theorem is definitely applicable here. I need to, again, write a sentence quickly to prove that I know what I'm talking about. All right, there's that. And now let's find the value of C, guaranteed by the IVT. We'll take the actual equation and we'll set it equal to this 4. Again, notice that x's turn into c's for absolutely no mathematical reason. Let's get a 0 on the right-hand side. I'm going to subtract 4 from both sides. I look at that quadratic equation for about 2 seconds and realize there's no way in the world it's going to factor. So I bust out the quadratic formula program. Again, if it's a non-calculator section, we're assuming you know how to use the quadratic formula. Opposite of b plus or minus radical b squared minus 4ac all over 2a. Generally, they don't make you do that by hand. Just plug it in. That gives us 2 possible answers. 5.408. I'm just going to round out to 3 places this time because the directions didn't say 4. So 3 is standard. So 5.4075, I'll go 408. And the other one is C is 0.092, but I quickly realized 0.092 is not between 1 and 6 as it needs to be. So I'm not going to write that one. And there we have it. The answer is 5.407 or 5.408. Okay, number 2 is a multiple choice question, and we're going to put the intermediate value theorem to use. The first thing I do is when I see a table or a chart like this, I immediately make a quick sketch. So here is my visual thought bubble, if you will. And I've graphed the points 0, 13, 1, 8, and 5, 6. I did not graph the point 3, C because, frankly, I don't really know where it is. And the question says, the equation y equals 4, or f of x equals 4, and we know that is a horizontal line, must have two solutions in the interval 0 through 5 if c equals blank. All right, let me go ahead and draw y equals 4. I'll just draw that right across. I didn't label the y-axis, just because, again, this is not a work of art. This is just my thought bubble, if you will. Here's y equals 4. And it says that f of x is continuous. So if I start from 0, 13, and I go through 1, 8, I eventually have to go through 5, 6. But I want at least two solutions, so I need to cross the green line. I need to cross it twice. I can't just bounce off of it. And so this would be the point 3, C. It doesn't necessarily have to be the vertex or the minimum, but it does have to be below 4. And I think you can see from the answer choices, only one of those fits the bill. Number 2, the correct answer is choice A, 2. All the rest are too large. All right, number 3, also multiple choice. It says that f of x is differentiable on the open interval 2 to 9. So not only is it continuous, but also no corners, cusps, vertical tangents. It's a nice, smooth, well-behaved curve. It says f of 3 is 12. It also goes through the points 6, -7, and 8, 12. Which statement or statements must be true? Again, I'm going to go ahead and doodle, so that'll just take a moment here. All right, so let's go ahead and see which one of these must be true. Number 1, f has at least one horizontal tangent. In other words, the slope has to be 0 at least once. Well, we're heading down and coming back up. So, I mean, it certainly could be true. We could have a horizontal tangent right at the bottom there. And, of course, I made an assumption that 6, -7 was a minimum, or a vertex, and there's really no way to know that. So I've established that it could be true, but I need it to always be true. It says which statements must be true. You know, what if it came down and what if the slope wasn't 0? What if it was like an absolute value type look or a jaggedy V shape? Then the slope wouldn't be 0 there. It wouldn't be a horizontal tangent. But I know that can't be true because the problem says that f of x is differentiable. And since it's differentiable, I cannot have a corner or a cusp. So that's out. But even if 6, -7 is not the minimum, it has to turn around somewhere. Maybe it hits it on the way back up. There must be a place where it turns around. And that place has to be curvy. It can't be sharp because the function's differentiable. So yeah, number 1, Roman numeral 1, must be true all the time. So that's in, which means that choice A and D are out. And I think as a good multiple choice test taker, you can see that choice 2 has to be true because it's in all 3 of the remaining choices. So I'm going to circle Roman numeral 2 as well. I think you can see that that has to be true by the IVT, the intermediate value theorem. If you go from 12 to -7, you had to cross the x-axis somewhere, and if you're going from -7 back up to 12, you have to cross again. So that has to be true. So that means that, actually, since 1 was already true, I should have gotten rid of choice C, so that's also out. It's down to B and E. So let's see if number 3, Roman numeral 3, is true or not, or has to be true. It says somewhere between 2 and 9, f of c is 10. And that is going to be true as well. The reason I know that is because f of c equals 10 is the same as y equals 10. Horizontal line. The graph must cross that at least twice. That, again, is intermediate value theorem because 10 is between 12 and negative 7. And you're actually heading back up again. So it actually occurs twice. And if it happens between 3 and 8, then certainly it's going to happen between 2 and 9 because 3 and 8 are in that interval. So, yeah, all 3 of these were true. Choice E for number 3. Okay, finally, number 4. This will be our last one. It says selected readings for the velocity of a speedboat are shown in the table. Okay, so let's see. Every 10 seconds, we're taking a reading, and the speedboat is getting speedier. It's getting faster, and then it does slow down a little bit from 30 to 40 seconds, not by much. All right, the question says, was there a time when the speedboat was traveling 35 miles per hour? How about 40 miles per hour? Explain your reasoning for each. Well, yes, there was a time when the speedboat was traveling 35 miles per hour, and this is intermediate value theorem all the way. You can see that you're going from 32 to 39, you have to go through 35. So that first answer is yes, somewhere between time equals 20 seconds and 30 seconds, the speedboat was going 35 miles per hour because 35 is between 32 and 39, and you need to mention by name the intermediate value theorem. So I will write that out right now. Okay, there's that. You do need to mention, as I said, the intermediate value theorem. IVT is fine. Graders understand what that means. And you also, when you use the IVT and some of the other theorems we're going to learn later, you have to show that it's usable, if you will. And the intermediate value theorem, as we learned, only works if the functions are continuous. So I'm going to mention that velocity of a boat is a continuous function. It doesn't say that in the directions. A lot of times it will. But certainly a boat can't just disappear and reappear from the earth. It has to be continuous. So that's the first part. Yes, the boat had to be traveling 35 miles per hour. How about 40? Well, if you look at the velocities, there's no evidence. All those numbers are below 40. Now, could it have been 40? Yeah, sure. I mean, it may have gotten up to 40 and then started to slow down there and gotten down to 37, but we do not have evidence. And so for the second part, we simply have to say no. So 35 miles per hour, yes. I actually should answer that question. I never actually did. Yes. Explain your reasoning. Okay, there I did. And 40 miles per hour, no. And it says explain your reasoning for each. I think I'll just say no. The values weren't more than 40 miles per hour, so we don't know for sure. Just put that in a quick sentence. And there you have it. All right, well, that's it for the third day of what I called section 1B. We learned the intermediate value theorem. We're going to see this a lot as we move forward. This will always be around. In fact, this number 4, I patterned it much like some of the free response questions that you will see on the AP exam. So that's it. I'll catch you guys next time. Take care.